Good morning and most welcome to 1399. We have a sunny morning here in Gothenburg in the outskirts, here on Hisingen Island, a central island close to the actual city. We will continue with Constructor theory, and I will take help with a little article written by Aleksandar Malecic. What does constructor theory construct? Knowledge as a physical property. What Chiara and David Deutsch are proposing is that there is no direct difference between hardware and software. The difference between res cogitans and res extensa becomes dissolved. Becomes less. Or I would say clarified. Previously, I found dizziness and lack of understanding clarity comes in. It is exactly like a summer's breeze when the weather has been too damp and sultry. It comes in and brings freshness, clarity and direction. One gets a feeling that one has left the blurry waters of res cogitans and res extensa. The dichotomies that has, to use a phrase of Rudolf Garcia, has nullified all of Western knowledge. this is how I metapound knowledge in the form of just dichotomies, false truth, in an endless chain. Not making any sense at all. Disconnected to the Umwelt, to use a Heideggerian term. Everything just hinges on oppositions, no fractal depth, to use a term from Susie Froebel and chaos theory. So I go into the article by Aleksandar Malecic, oddly at the University of Niš, where I happen to have a friend. It's a small world. Constructor theory of eigenbehavior is the most appropriate short way to describe what this paper is about. To those who have encountered the idea of eigenbehavior for the first time through this text, let's say that it is related to recursions within and emergence of consciousness and information in general. in a back and forth manner between constructor, theory of possible tasks, and eigenbehavior as a viable phenomenon. We shall try to say something about the fabric of reality. This author uses in an already published paper, Malecic, 2016, the metaphor of systems as footprints, and wonders what kind of animal might leave them behind. My comment here, I thought about the trace when I read this about the footprints. This text goes further in combining and criticizing Deutsch and Marletto's work with the concept of eigenbehavior. Interpretations of quantum mechanics and physical principles are also elaborated. Introduction. Causation, the arrow of time, consciousness and computability cannot be resolved only by additional empirical studies. The problem is unresolved if scientists add conscious entities as an afterthought. And refuse a systems perspective and transdisciplinarity. how to use the system's perspective in order to gain insights not possible by any other approach. Where does physical principles come from? How to set an agreement that is collective eigenbehavior about conclusions. Different ideas are compared through the system's perspective in order to support those that unify and criticize those that do not unify. David Deutsch and Chiara Marletto's Constructor theory. Can be used to both assess their own opinions, eigenbehavior, and reveal something about thermodynamics, quantum mechanics, and causation. Consciousness is a possible task within our realm. It belongs to viable systems and viable physics of viable systems. The conclusions reveal something about a viable reality and us within it. similarities between constructor theory and constructivism go beyond similar words. Especially because Deutsch himself announces that there might be some publications on cybernetics not known to him that could improve his and Marletto's ideas. Just as physics is valuable for naturalization of metaphysics, it is valuable to look for physics of constructor theory and constructivism. And in a back and forth process, akin to Troncalis abstraction and de-abstraction. Question viability of approaches, for instance, Maturana and Varela, Rosen, Hofstadter and Deacon, and physics. My comment here is that it would be apt to contact Aleksandar. Constructor theory and eigenbehavior. First of all, we should elaborate two still not widely known concepts that are the key part of this article. Constructor theory and the fabric of reality. The following definition is the central idea of this article. We shall insist on it even in cases when something looks unexpected, counterintuitive, or inevitable. Constructor theory is the theory of which transformations, that is, input state of substrates, give output state of substrates. Can be caused and which cannot and why. It is a search for physical principles allegedly more fundamental than physical laws. I'd say this is very important. I'll repeat it. It is a search for physical principles allegedly more fundamental than physical laws. Instead of doing physics as usual based upon initial conditions and physical laws, Deutsch and Malletto are foremost interested in fundamentals of quantum computation. But also want to know deeper truths about other phenomena, such as information, life and thermodynamics. comment here is, this is what got me interested, was information and knowledge. How do you get closer to knowledge and understanding? This idea isn't entirely new, but the way Deutsch and Marletto frame the discussion with their definition is. Similarities behind loosely understood constructivism and constructor theory are not just in similar words. But also in their approaches to expectations from reality and scientific work. It is a similar mindset when we try to understand minds by shadows they cast. Or systems by footprints they leave behind. It makes sense to focus on the four strands of what Deutsch calls the first theory of everything. The following four. One, quantum physics. Quantum physics arguably goes deeper than any other physical and scientific theory in defining and understanding building blocks of reality. Deutsch sees Everett's many worlds interpretation of quantum mechanics as the ultimate theory of physical reality. My commentary, that's a bit of a shock. Two, epistemology is related to knowledge. What can be known and how. Deutsch disagrees that the main role of science is to predict phenomena, but rather to explain them. My comment here, that would put him in the same category as Smolin, Barber, and Maturana. According to Deutsch, the major epistemologist is Popper. With his idea that any scientific data, rather than directly, can only be interpreted through theory. For those of you who've forgotten, that is called Popper's main strand is falsifiability. The theory of computation. The goal of a developed constructor theory would be the universal constructor. Universality is achieved when a set of characters, rules, regularities, or some abstract entities can fulfill the role of expression or sharing of meaning within a system. Turing machine is a universal computational device but not a single strand, including this one, represents on its own the whole reality. Fourth and last one. The theory of evolution. Besides the obvious association with Darwin's theory, this strand can also be about causation and emergence. Within physical and natural systems. It should be open for discussion whether the theory developed from these strands can reveal something about general systems theory. But a theory capable to do that would be a strong counter-candidate or improvement to other suggestions such as Miller, Soma, Palmer, Prigogine and Rosen. The strands should be modifiable if they, under modifications, provide better explanations of reality and communication, unification of each with the other three strands. Deutsch himself sees his work on the strands as unfinished, and the research on constructor theory is a continuation with its search for physical principles. If we assume that the strands and the principles, as defined by Deutsch and Marletto, or in some other way are on a comparable level of abstraction, it isn't clear how they emerge from each other. The principles suggested by Deutsch and Marletto look arbitrary because they are being added on a list until they seemingly cover reality. On the other hand, the aforementioned list of strands seems to be difficult to vary as something that someone from another planet might suggest as the same or a very similar list of strands the fabric of reality is made of. Let's take, for instance, computation. Logic and Boolean algebra does not exist out there as physical objects directly accessible to lay people not interested in mathematics. But that doesn't make them less real or less difficult to vary by a different scientific theory. Any civilization that cares about scientific rigor would develop the identical theory of computation and the use of bits or qubits, even if they had its own Gödel. I will make a little summary there. So the object of Aleksandar Malecic is to look deeper into what is understanding, what is information and knowledge. The footprint could be compared to the sign, and the footprint is the materiality of the sign. Often forgotten, you look at this number 7, it is made of an abstract idea, but it bears a trace of materiality, a footprint. Having graphite, paper, and also inherently there is a footprint of my hand, a handprint if you like. I'll say this is helpful to easen up the tremendous chiasm between signifier and signified. And that chiasm is getting smaller in the theory that David Deutsch and Chiara Marletto is developing. It is still in the process to gain more understanding and knowing. And I do agree about the motto, any civilization that cares about scientific rigor would develop the identical theory of computation. This is tantamount to understanding the why question. Maybe some comment from my dear colleague here, Kalle Lundahl.
Hello from this office at Värdegårdsgatan on the island of Hisingen. So far as I understood Deutsch, he is looking for the grand theory. He wants everything in, so to say, in a theory, in a box, if you to simplify. And I would like to comment on the last phrase in the paper by Malecic. Any civilization that cares about scientific rigor would develop the identical theory of computation and use bits or qubits, even if it had its own Gödel. And here I would like to make 2 points. One is that I hope you, Hans, could consecrate a lecture on to Gödel this week, Gödel. And then, so for Malecic, as he rephrases or phrases the sentence, for him Gödel is something negative, even if it has in Gödel. So Gödel shows the exceptions, roughly speaking. So if you have a theory, there is what should you do when you have exceptions? So you marginalize the exceptions to your grand theory. Get back to you in my ignorance about this things. Wait.
I am very interested in Gödel and what Malecic has to say about him, and most definitely we will enforce a good lecture. I saw the interesting connections, and the Gödelian project is hindering us from getting too possessed by the unified idea. What Marletto is pointing to in the book Can and Can't is coherence and consistence cannot simultaneously be achieved. It's more like a net. And I always been thinking about Indra's net. It's an everlasting, ever rebuilding net. And the identical theory of computation is more an engine. This is my take on it so far of the lecture, but I will get back to it later when we make the last summary. Put a pause. So we got some sunshine, and I will conclude the first lecture of the day. And I am not now at page number 1, 2, 3, 4. We're getting into eigenbehavior. Eigenbehavior. Eigenbehavior from Pangaro is an attempt to bring back observers into physical systems with their self-organization and self-reference. It resembles what Dodig Serkonovich calls physical computation. Dynamics embodied within and distributed through a system rather than written as in a software or hardware. This is crucial, I would say. I'll repeat it. Embodied within and distributed through a system, rather than written as in a software or hardware. You're more than welcome to put in res comitans, res extensa into that parallel. The meaning and causation are more compatible with Peirce's representational relationships of icons, indices and symbols than with the de Saussure's element by element mapping between signifiers and the signified. It is about the difference between the physically real and the modeled. Let's find together the longest word in English language out of the letters. G, N, A, I, P, N, I, T. The author will wait for a few seconds before you find it. All right, now when we found the same word, let's try to recall how we did it, because that's how physical computation seems to work. Were you permuting letters and looking for matches in your dictionary? Did a few seconds of parallel computation, the way a good neural network would, or miraculously pull out a single word as if it were a rabbit? Shaped in a strangely looped way, resembling hands drawing each other from Escher's graphic mentioned by Hofstadter, in a magician's hat. whatever you did, that's how physical computation works. There's a difference between before, that is trying to find the longest word, and after finding it. But was it really a causal chain with causes taking place before effects, or rather a fog lasting for a few seconds, out of which the word was gradually emerging in front of you? How would a deterministic computer do that? Muting and looking each time in a dictionary, or parallel computation of an artificial network, are both good deterministic approximations of how we deal with this task. But are they the whole story? If I try to set myself into a contemplative and self-observational mood, it seems to me that it is similar to the handshake in the transactional interpretation. Mind you, this does not mean that quantum mechanics implies consciousness, or that a question whether or not it implies consciousness can be properly posed. We are just comparing physical computation as dynamics of form in quantum objects and mind to its desktop equivalent. To be honest, it would be cheating not to mention that artificial and deterministic neural networks as opposed to regular computation and algorithms do get closer to some aspects of physically embodied computation. And that this essay on its own fails to be universally convincing. It is up to the readers to do some extra thinking and contemplation on the topic and see for themselves. Whether or not this essay at least provides hints about why PTI and emergence all the way down is the most physical computational friendly interpretation of quantum mechanics. If the many worlds interpretation is right, does that mean that some of your parallel selves have no idea of which word I'm talking about at the beginning of this paragraph? Interpretations of quantum mechanics Interpretations of quantum mechanics are elaborated not to contribute to discussions such as whether consciousness is a quantum phenomenon or quantum mechanics implies consciousness. There are more interpretations of quantum mechanics. But the two arguably addressing constructivism, structuralism, more than others are the Everett many worlds interpretation and the possibilist transactional interpretation. My comment there is the author used an acronym earlier on, PTI. It's referring to possibilist transactional interpretation. Zenkin compares actual infinity and counters diagonal proof to the liar paradox. This kind of infinity resembles infinite regress, and as such is disconnected from physical reality. Also, it should, whenever possible, be avoided from any new physical theory. Also, it should, whenever possible, be avoided from any new physical theory. The Everett interpretation claims that every possible quantum event actually happens in some kind of parallel world, and the transactional interpretation is about offer waves. Confirmation waves and quanta. The possibilist version of transactional interpretation is supported in this article. See space-time as emergent. And possible transactions negotiating outside of space-time and empirical realm. These two interpretations are arch enemies because they are both related to systems worldview applied to fundamental physics. In a way similar to Cantor's failure to acknowledge the difference between potential and actual infinity in set theory. The transactional interpretation is about potential events, and the Everett interpretation insists on an infinite amount of actual events. Out of other interpretations, it is worth mentioning here the Copenhagen interpretation. Because it is about consciousness causing collapse of the wave function and the objective reduction interpretation will keep the promise of not directly talking about consciousness and quantum mechanics, and do that indirectly. question whether consciousness is a quantum phenomenon makes as much sense as whether a molecule is alive. The aforementioned interpretations do not require consciousness for the existence of quantum phenomena, just as consciousness is actually rare and still relatively short-living on the cosmic scale. The sub-empirical world Kastner writes about may be the realm from which consciousness has emerged. But it does not require consciousness for its existence. On the other hand, the fact that eigenbehavior does exist might reveal something about reality we live and eigenbehave in. Retrocausality is related to the transactional interpretation. See Kastner's elaboration of this concept. And critique of time-symmetric interpretations. Constructor theory of eigenbehavior. An alternative definition of constructor theory is about which tasks are and which are not possible. and the word possible in both this definition and the possibilist transactional interpretation of quantum mechanics. Is far from coincidence, even though Deutsch and Malletto refuse to leave Everett's burden behind. If we eliminated or didn't insist on the use of its definition, we would not have constructor theory anymore. That being said, it is a strange situation that Deutsch and Marletto rarely apply their own definition and prefer short metaphysical statements without asking whether or not that is how reality functions and why. For an example on how to prove that a theory, the Everett interpretation, is impossible and why, see Jeknik, Dugik and Frankon. Instead of just mentioning that something is inevitable, provide a reference and move on. Dugik et al.'s article provide an in-depth elaboration of systems and Brownian motion. Constructivism. The author is implementing in this paper an approach similar to constructivism, but does that in a way that other proponents of constructivism might not approve. System science requires a radical change of perspective, and this is where the constructivist approach is helpful in encouragement of open-mindedness about reality and ideology, and playfulness with mental constructs. Serious modifications of everyday thinking are necessary in order to comprehend counterintuitive aspects of reality. And this, my comment here, this is a claim I do myself. Counterintuitive aspects or counterfactual, it's a practice. It cannot be comprehended. It needs repetition, training, and demeanor to make it happen. There are connections here to the case of constructive mathematics. And I will include that thought into my summary that here comes. In ordinary mathematics, or rather the mathematics that has been the absolute majority since the beginning of last century, beginning of 19th century, and the Hilbert-led conference in Paris was dominated by a specific kind of thinking. That takes the use of the law of the excluded middle as its thinking process. This becomes habituated and unconscious. To make a great simplification, this habit was well established within Gödel when he made his discovery that that path would not take him where he wanted. Brouwer and later Bishop showed that a specific habit of thinking was ruling mathematics. And they showed that there was a way of making mathematics. Sorry about the sound, I think it was a bit distant. They found a way of doing mathematics that needed severe retraining and not the use of LEM, law of the excluded middle. And as in this case, it has close connections to computational theory and the quantum computer. Rather than the more and more deviating mathematics as a subject in itself. I would say the counterfactual can be learned, and it's a key to understanding in a common way without complications the very kernel of quantum mechanics. So, in that fashion, it is very similar to constructivist mathematics, as it has been expounded by Bishop and Brower, a naturalization of mathematics. When it comes to counterfactuality, the habit is ingrained in our everyday thinking. And I would say it's a heritage that goes all the way back to the thinkers of antiquity. So it's a foundational habit of seeing the world, one that was discovered to obscure physis itself, that is the material world. In the discoveries of the 1920s. Maybe a comment here from my colleague, Dr. Lundahl.
Thank you. Back from Väderkvarnsgatan on Dala Pissingen. I would like to repeat one phrase on page 4, the last phrase on page 4. If, so Malecic writes, if the many words interpretation is right, does that mean that so? How many of your paradoxers have no idea of which word I'm talking about at the beginning of this paragraph? Let me repeat it. If the many words interpretation is right, does that mean that some of your paradoxers have no idea of which word, a word with 4 letters, I'm talking about at the beginning of this paragraph? After reading Macilcrist, this sounds very schizophrenic. I think we have spoken about this in the past, that the many words interpretation sounds, the adherents of that sound very schizophrenic, as described by Macilcrist in his book Mazarin's Emissary. So, in this sentence by Malecic, the information is, so to say, split. A little bit there, a little bit there. And I think also in this almost a homonymy in English, word and world, there is a clue to this split. Using that, so let's say the average many words interpretation right. Where should you have the knowledge? Is it not in language, for instance? So can this knowledge, language, be in, let us say, in the outer space? It sounds a little bit bizarre as a theory. What do you think, Hans?
Well, thank you very much, Kalle. Excellent comment as usual. So beware, this is rather complicated. In the Everetian conclusion, and of course the one of Max Tegmark, there is still a divide between material and abstract. Tegmark and Everett were both Platonists when it came to mathematics. Here, Platonism doesn't subside, and there is no difference between sign and signifier. What does that mean? Well, I have to make a guess here. I do not know exactly where the conclusion will end. But as I think, it could be that when signifier and signified comes together, so to speak, there is no longer talk about platonically real worlds. There are more calculative systems, and the most possibly schizophrenic mind of Everett has produced only the calculations, but not, so to speak, an ontology. I believe, my guess, to be more honest, is that Tegmark wouldn't be too happy with the constructivist manner either. But at this point, I have to be honest and say I am not sure. We'll wait and see. I think we've rounded up there. Thank you very much for your comment. And we continue with the next lecture, which is actually a whopping centennial. So we take a break here and back soon. Thank you very much.
Thank you.